talk to us about code of conduct.
Thank you. I know all of you are very eager to leave this room and check out all these amazing sites. Just by a show of hands, how many of you know what codes of conduct are, or you've heard about them? And how many of you think they are a problem and shouldn't be there? OK, well, we are here to talk a little bit about what my work is. It's not going to be only about the work I've done with the kernel, but it's about various communities. I am the legal director of Software Freedom Law Center. I am a lawyer who's represented most of the world's prominent open source software projects. And here we are to talk about what is special about these codes and why they exist and why they are not such a problem. But if you do have objections, I'm happy to discuss, and that's what we will be doing. We all know that a fundamental change is happening in the way software is made in the free and open source software communities in this century. Your communities are now mature, and the people who work there, which is you, understand your workplace differently. Over a decade and a half, what has happened is that more and more companies now employ developers to contribute to FOSS. And the communities have become diverse, and different expectations have begun to emerge from all stakeholders. These global communities, like the one present in this room, have narrower social interactions, say around a water cooler or in person. Therefore, putting a premium on the way your internal intermediated communication is conducted becomes necessary. In this talk, we will examine why codes of conduct in this new world are on the rise and actually are a positive sign for mature FOSS projects that govern themselves and don't like people like me, who are lawyers or the ones who wear suits. Later also, we will explore ways of managing legal risk by drafting codes of conduct that address bias, create a frictionless reporting mechanism for any legal incident response, and making the project at least a more inclusive, productive place for everyone. Now, this first slide, as you see, talks about the issues which are particular to FOSS communities. Usually what has happened is, and this is not just FOSS, but a lot of technical communities, there is a little lack of diversity in the talent that works here. I'm not saying that things haven't improved, but we have a long way to go. There is a lack of structure and rules, which in the FOSS communities have historically been viewed as cultural benefit. There are factors that may disparately affect minority groups. There are time demands. There's work without pay, because a lot of software does get developed as volunteer work. There is a lot of premium which is put on personal reputation, which is highly prized, and who you know matters, which reinforces the homogeneity of the culture that exists in these communities. Now, does it really matter that all this exists if you agree those problems do exist? If it does matter, then why does it matter? By now, most of us have read the widely circulated HBR article on the diversity dividend. If you haven't, obviously it's readily available, and you can just Google it. Now, it does say that diverse teams achieve better performances. And a little fact in our community that venture capital firms that increase their proportion of female partner hires by 10% saw on an average a 1.5% spike in overall fund returns each year and had 9.7% more profitable exits. This is an impressive figure, given that only 28.8% of all VC investments have a profitable exit. Now, this also matters because if you have diverse teams, then you can actually build fairer products. And your products are now reaching everywhere, to everyone, and are running the world. Now, FOSS does also have a great potential to allow minority groups to succeed and provide an opportunity to succeed, because there are free tools, there is meritocracy, that also makes it very special and easy for people who generally haven't had a chance to succeed, an opportunity. Now, why codes of conduct? The codes of conduct are nothing to be afraid of and great for people who make software. The first reason, the projects now have become the workplace for many of you. Many of the free software programmers, your primary environment in which work gets done is the project. It may not be where the paycheck comes from. A lot of FOSS development is volunteer work, but it's also true that a lot of companies now pay programmers to work on free software. And these companies tend to be relatively sophisticated, large technology organizations that are investing in FOSS because it's good for their business, and they have rules of the workplace, standards, and all that sort of stuff of their own. But the programmers who do work are trying to deal with the conditions of work in their real workplace, which is your respective project, and not those companies. We just thanked a lot of sponsors, and these sponsors also sponsor development. A recent entrant to the game, Microsoft. If you see Microsoft's open source code of conduct, it reflects exactly that. All Microsoft employees, as Microsoft says, enjoy a safe work environment and a culture of mutual respect and responsibility. They say that our team members and open source partners should enjoy the same environment when collaborating on open source projects. And that is why they insist on these codes of conduct. Now, what these codes of conduct represent is the effort by the community at industrial democracy, or if you want to say it, contributors' self-governance in the real workplace, which is the project. And what is happening is the amateuration of the contributors' desire for humane conditions of work. The projects have now evolved to a much more sophisticated workplace. This is not being done through adversary bargaining or collective union-managed bargaining, or in any other ways in which employment law is traditionally made. It's being done in your style, like free software style of development, which is of open collaboration among the contributors themselves. This is a very positive maturing step in the process, which should be greeted as an opportunity for everybody who works in the project space in large, international, cross-cultural collaboration to evolve the rules of the workplace that suit everybody's needs. This is the form of industrial democracy appropriate to the programmers working in the collaboration of free software in the 21st century. It involves making rules for the workplace, not in national legislature of your own countries, and not through adversarial bargaining with the employer who pays the rent, but in the form of free legislation that you write, you develop, and you also make the rules for enforcement. Now, and it is made through consent and operated through their own evolved processes. Listening. What is crucial to helping contributors, such as you, achieve what you're looking for is listening to you. Listening to the contributors, to the developers or workers. Yours is not a top-down system. It's a bottom-up system. And the lawyers, governance authorities who are helping to bring this system into existence are primarily engaged in listening. That's what my job is. Sometimes I am just billing only to listen to other people. Part of the reason that this is so important is that people need to be heard in the free software workplace. Because without voice, there is no adequacy of participation to cause people to come together and do the work you do. You do this work so that you can talk to one another. Mostly, of course, you converse in code, which is an important language and social structure for all of you. The program itself, but the program itself is not everything. For a while, when the workplace of the project was comparatively homogeneous, comparatively socially, culturally, ethnically homogeneous, and largely consisting of people of similar age doing work together as they were beginning in this industry, this was fine. During that period, it seemed like that listening could occur only through code, which you wrote. And really, what you needed to do the work after Linus invented Git was Git, a mailing list, and some kind of a bug tracker. And that worked very well for a lot of people. But it doesn't scale. And it doesn't scale across all of the humanity. And the process of listening is very much more socially complex because the organization of your communities has become very different. So what is happening now is that people are learning how to listen to one another differently. Some people are responding to this with great eagerness. They want to help their communities. They want to help their communities construct ways to listen to one another better, to collaborate better. Some people think the old ways of listening were good enough, because indeed, they worked very well for them. But slowly and with very great significance, with real meaning, people are learning to come together in order to change the way they communicate to make the workplace more humane and productive for everybody. There is pushback. Of course, there's pushback. There ought to be. And there are people who think that this is somehow aimed in a hostile way at the way they communicate, because the growth and diversification of your project implies change. But there isn't any intrinsic tension between the ways of communicating that worked before and the ways of communicating that will work better now. And I'm not just making these rhetorical statements, having worked with a very, very large variety of free software projects, as well as the commercial sponsors of these projects. That's the only gist of the learning I've had about different ways of communicating with each other so that your eyes stay on the prize, which is making great software. Now, the primary role of the professionals, particularly the lawyers or the governance people who come in, working in this area, again, is not to take the center stage and play a very active role. Our primary role here is to make sure that everybody understands that there is no conflict between fairness and kindness. You can be fair, you can be just, but you can also be kind to the people you work with, especially when those people come from different cultures, different nationalities, different understandings, different genders, and various other ways that they define themselves, not the way we understand them. So our primary role is to make people understand that there is no conflict between fairness and kindness, that the rules that we all are evolving for the workplace, that is your project, where you spend most of your time, and for the community's interactions, do not balance our kindness to one another off against our justice or the sense of fairness to one another. These rules are geared to the achievement of both of these. In the same way that, I'm going to take and perhaps an unpopular example, but in the same way, unions of contributors are designed not to create an illegitimate power, though obviously all power can be abused, but to give contributors a form of self-expression and self-determination that is both individual and collective, and which provides both justice for contributors overall and fairness and kindness and mutual support amongst yourselves. And what does it actually mean into practice? Nations write constitutions, then they write laws, then they write other stuff. Companies write policies because there's an employer-employee relationship and there's bargaining there. What do projects do? Projects write their own ways of governing themselves. And now they write, now they write code of conduct. It could be called something else, but that's what is becoming now. Now, adopting and writing a code of conduct firstly means that having a clear and accessible document which just states the norms under which projects operate. Now, this will only help you address any issues that may arise. One thinks that there aren't any issues, but most often what happens is that you aren't ready when the issues actually arise. And then there is public backlash, then there are other issues which come up. Now, an issue resolution process for addressing the cases where these norms are not being maintained is an essential part of such code of conduct. And as I said, we are not here, or anyone is not here to force anything upon the communities. It's mostly to understand how is it that you want to work with each other? What are your rules? And that's why when you, the general principle is, why don't you state the purpose of what the code of conduct will be? Why don't you identify the specific expectations of behavior towards each other? How do you want to be treated, and how do you want others to be treated in this project? What is your vision for the project other than just making great product? Now, it's very important to define the scope of the code of conduct. Does it apply to all your interactions? Does it apply only to conferences? We all know that conferences are an integral part of how your community interacts with each other. You all have spent a week here because you think there's real value in getting together and working together and meeting in person as and when it is possible. So does your code of conduct apply to these conferences, only to the conferences, or to all kind of interactions? To your mailing list, to when you talk on phone, when you get onto IRC chats, or whatever is your mode or preferred mode of communication. So identify the scope. Set expectations by publishing reasons. If a committee is defining a code of conduct, you also owe it to each other why you are saying certain things. Because as we all know, this is not a top-down system, but a bottom-up approach. And everything happens once everybody collaborates with each other. So set expectations, publish reasons, have discussions, and at a conference, if you are there, promulgate code of conduct at time of registration, the talk submissions, and at the conference itself. Be clear that code of conduct covers official, unofficial conference events, and what is the enforcement process at such conferences or whenever an issue arises. Do not adopt consequences of violating the policies that you wouldn't be willing to impose on your highest profile attendee. We all know that there are superstars everywhere, but that superstar status should not get anybody a free pass. That's how we make fair policies. So you'll have to outline the reporting enforcement mechanisms, identify specific persons or titles to handle problems, and ensure that there is an identified personality to whom complaints can be taken to. If you want models, these are some of the models or templates people have adopted. You don't have to adopt them all in entirety. Each project adopts something which is specific to them. And you can all have opinions about all of these, and you are entitled to. But at the end of it, whatever is your project, whoever are the members of your community are the ones who will decide what you want the rules to be. There's geek feminism, there's a contributor covenant. There are popular projects like the one Linux Foundation now has adopted. The companies, Twitter, Ubuntu, Microsoft, Facebook, everybody's open source projects have their own code of conduct, and you can decide what you want from that. As I was earlier stressing upon, that an issue resolution process is very, very important. You will have and follow a written resolution process. If you do have one, then stick to your guns. Enforce the written policy. It is critical that everyone in the communities be aware of what the code is and what the process is. For that reasons, most projects link to the code of conduct in the README or a contrib files using a markdown language. There are common pitfalls, and we're not going to cover everything today here, but some of that which I often see is inconsistent enforcement of what is written. You write something, you don't enforce it, people just lose trust in the process. It's not very complicated, it doesn't have a lot of legal jargon. We don't encourage projects to actually adopt stuff which other people cannot understand, or you need a law degree to even decipher. We're not writing privacy policies for social media companies. We're writing something which you all can understand. So inconsistent enforcement, a not clear issue resolution process. If the issues are reported, there's no acknowledgement. There's no assignment to who's going to be resolving it. And there's no in-time resolution. There's also a risk that code of conduct is seen as politicizing open source. Those who see it as an attack on meritocracy of coding. Those who see that this turns somehow everybody and turn the project over to social justice warriors. Nobody's interested in that. Nobody's attacking. The only thing which people are asking is, we all work together. Why don't we just have certain rules about how we talk to each other, how we interact each other, and if one of us is not following those rules, then how do we deal with such an issue? It's your problem, so your solutions are the ones which work best. You only get professional help to make sure that at least you're in compliance with whatever your legal obligations are, or in order for you to have a streamlined process which makes it simpler and easier and rely on someone else's experience to build something which will work. Now, in my experience helping communities to do this thing, people's fear and fear of the new form of this democratic self-governance is a barrier to progress. The actual work of building these processes inside free software projects is most difficult. Having worked with large and significant projects that are technically and socially very sophisticated. The most difficult part of this is getting the steering committee or the project leaders or whoever you have in a particular project to actually make decisions. And the reason this is so difficult is precisely this feeling that it's about social conflict or social justice warriors, or whatever you want to call them, which is making people who need to provide leadership more timid and not be able to actually do what they're supposed to be doing. This is a statement from a project I have worked with. If some of you recognize it, it's this small project called the Linux kernel. They now have a code of conduct. This is the reason they actually came up with, why they are doing so. And this is an example of actually a really important project in which leaders realized what needs to be done. They're changing their behaviors, and they're really leading. They're not dictating. They're not throwing people out. They're not doing anything that their members are afraid of. They're saying we want to have a better workplace, and we're all going to work together to make a better workplace, and we are all going to make decisions in the same way we want our workplace to make decisions better for everybody. And this is the spirit in which we should all be engaging, not to see this as an occasion of tension among contributors, but to see this as a growth and further maturation of the way that programmers around the world contribute to this particular project. Having discussed all of this, I don't think there's anything more useful to say about this than was said by this Democrat, if you do follow US politics, who was a great believer in self-determination, Franklin D. Roosevelt, when he said that you have nothing to fear but fear itself. And that's why a lot of processes around the codes of conduct do get impeded and have obstacles, because people are very fearful of approaching this very subject, which is so much under their own control. Now, if you do face such a way, or you're facing such a problem where you think that people are so fearful and your own leaders are not going to be doing what they think they are expected to for any reason, that's the time when you call in some other people from outside and help you work along with your community. Obviously, this is a plug. This is my name, and these are my email addresses. This is what I do as for my profession to make my money. Or if you have any other free and open source software-related questions, this is where you write. But all I will say is that codes of conduct are what you decide and what you enforce. And because diversity in your teams is better and also helps make more fairer products, then don't fear, just get in, dive into it, and you will come up with something which is going to work for everybody else. Thank you very much.
Thank you so much, Mishi. Got everything? You can take it.
Okay, I'm done. Oh, do we have time for questions? Or we can just move on?
I think we should keep going.
Yeah.
Sorry. But thank you for coming. Mishi's actually based in New York City and Manhattan, so we really appreciate having her here today. And our next keynote is someone who's familiar to many of us and someone who's been involved and a leader in open source for quite some time, Rob Oshana from NXP, and he's going to talk to us about open source building blocks. Please join me in welcoming Rob.
Oh, yeah, this is. All right, thank you. So last speaker for the week, I guess. So I'm going to talk about how we're leveraging open source in a mass market environment in the microcontroller group at where I work at NXP. We have a pretty large portfolio of devices from, like in that graph, from very small end microcontrollers, M-core type stuff, all the way up to high-end heterogeneous multi-core processors, a couple hundred products in total, and we have to provide software for all of it, okay? So we can't do it without leveraging open source and partners and communities. And so what I'm gonna talk today is about how we do it and how we laid the foundation to be able to leverage open source and how we're moving forward with that, and just share a couple examples with you. So as you can see, quite a lot of customers in a mass market environment. And so what we do is we basically provide a couple different software products. One is a Linux release. It's basically a Yocto type product for all of our Linux-based devices, our A cores, and then we have a software development kit. On the Linux side, mainly Yocto, but we're providing additional distros for out-of-box experience as we provide more vertically oriented applications. So that's kind of evolving, and we're leveraging the community distros for that. And we look for reuse and scalability, because obviously these can't be point solutions because we have so many different products. In the middle there, we have between microcontroller and microprocessor, we've kind of defined that intersection as a crossover processor in our world, and it's kind of that, it's not quite a microprocessor, a little bit high-end microcontroller, so we call those crossover processors as well. But that whole chart there is about just over 20,000 unique customers, so quite a lot of activity. And we let the community help us. And as an example, a lot of our legacy devices, those that are several years old, we do not do any software support within my team. It's all done by the community. About a quarter of our revenue, in fact, is from legacy devices that are supported completely by the community. So that's great, because we don't have to do it. We wouldn't be able to do it with our size of our team, but we work closely with our community, and they do all the support. Okay, now things are changing, and as an example, I'm going to use the very common theme in the industry today. I'll share with you an example of how we're on top of our enablement, we're trying to build other building blocks for technologies like AI and other IoT-based technologies. And this is ramping very quickly as well now. So we're going from base enablement all the way up to kind of full application reference designs. And how do we do that as quickly as possible? Because this is moving very quickly as well. AI itself includes cloud-based enablement, edge computing, all the way to end node. And right now, we're trying to address those challenges across all three of those tiers. So this is, I'll use this as an example as you go forward. You know, when you talk about something like ML, this is just showing the three tiers in a different form here. You really need to look at this as an integration play where you're integrating technology components from, say, an end node and some edge computing technology and all the way up to the cloud. And you have to really work across all three tiers. You can't just say, well, I'm doing the enablement, so I'm going to focus down on the, at the endpoint. You really have to look at how this integrates across the edge node and all the way into the cloud with different cloud infrastructures, different edge node technologies and gateways. So it becomes a cross product that ends up being very, very large. So how do you manage that? So I'll talk about how we're going to do that. So the approach we took, and I tried to simplify this, there's a little bit more detail to this, but the approach we took, kind of 3 steps: establish and maintain a base of upstream software that we can manage and leverage. So we try to work from upstream. We don't always achieve that, but that's our goal. Then, architect, or I guess I should say re-architect those parts of the software stack in order to accommodate open source more easily. So we have to do some of that. And then finally, leverage other open source components in the industry and then become more of an integration house. And so what I'm telling my team, for example, in machine learning is we're not reinventing everything in-house. We're going to leverage what's available in the community. And then we're going to be an integration team. We're going to integrate, optimize for specific use cases. So more of an integration play as opposed to start from scratch or NIH or whatever you want to call it. So I'm going to kind of walk through just a couple examples of these 3 steps and what we've done. And again, just as an example of how we tried to tackle this problem. So number 1, build a base of upstream enablement. So we've tried to institutionalize this a few years ago where we have aggressively pushed all of our technical debt upstream and we manage it. So I get a report similar to this every 2 weeks that shows the progress on our upstreaming progress, the remaining technical debt. We like to be totally upstream, like I said. We don't always get there. We fall behind occasionally. But we manage the data in such a way that we understand where we are because some of our customers will only work from upstream. And so we've increased the training in our team. We actually are building a open source manual now that actually has actual contributor maintainer interactions that we've pulled and used them as examples, and we're training people on how to do this more efficiently. And you can read the data there. I'm not going to go through it all, but we are taking this pretty seriously. We've increased the number of contributors and the amount of effort focused on establishing a very solid upstream. So this is an ongoing effort, obviously, but we manage it at the staff level. We look at metrics, we look at the data to make sure we're not falling behind too much, and that's necessary to form the base. So that's an ongoing activity. We also have found several areas where we needed to make the decision to re-architect software in order to accommodate other open source components. And just a couple real quick examples that I pulled that we worked on recently. On the connectivity side, for example, we've had to go through and essentially refactor, re-architect some of our connectivity stacks to partition it into in a way that allows us to more easily drop in different components from partners, the community, what have you. This example here, this simplified example, shows some yellow blocks where the software represents very device-specific software with well-defined APIs, and those pink boxes are the upper-level connectivity stacks, some of which could be in-house, some of which could be community, like an open thread stack, or a partner. And after we went through the painful exercise of refactoring this, going forward, it made us much more able to react quickly to different scenarios, different stacks, different partners, what have you. So it takes effort, but once you get through that, it's making our life a lot easier. So we've done this in a few areas to allow this to work a little bit more efficiently for us. The other thing we've done is, if you're familiar with some of what we're doing in the microcontroller area, we have a tool set. We call it MCU Expresso. It's free. You can download it. It's available to everybody. We build that in-house. But one of the things we started doing more recently is kind of shifting more to the left. We've got our tool set. I don't want to call it necessarily a walled garden, but it's kind of the commercial, download it, use it, very specific to what we're doing in NXP. But then on the left, we're leveraging platforms like Zephyr to enable us to put together other components very rapidly. And we're doing this right now, where we're using Zephyr as a base platform, and we're porting other technologies that are useful to us, like MicroPython, little VGL, et cetera. And we're able to strategically put in place solutions based on a Zephyr-type platform and port it very, very quickly across our products, usually in about 3 days or less per device. So we're moving to the left as part of the strategy. We're going to keep our tool set, but we're going to provide further enablement with the community. And we believe we're on the right track, leveraging platforms like Zephyr, which obviously is part of what we're working on here in Linaro through Light. So the platform could end up looking something like this, where we've got a base platform. It could be, we support FreeRTOS as well, but Zephyr, for example, we wanted to make it, our goal was to make it scalable and portable across all of our microcontrollers, about 125 different total devices. We're not going to do all of them, but the ones that are important to us. The idea, ease of use, plug and play, very rapid ability for our customers to prototype. MicroPython, I actually think, is probably taught more now than C and C++ in some universities. So we're just trying to change the landscape a little bit from where we were to more of this community-based enablement platform. So this is what we've done, and this is what we're going to continue to do from on the microcontroller side of our portfolio. And then third, so now we've got the base platform there. We've re-architected software in order to accommodate more community-based contributions. And now let's try to leverage these open source components and be able to scale more than what we have in the past. So like I said, as an example, like I mentioned earlier, from low-end microcontroller, M cores, to high-end i.MX, in the middle, kind of that crossover processor. We call it RT, where as you can see there, it's cores plus acceleration like a DSP or a 2D GPU, what have you. So it's right in the middle there. But how do you take that software enablement and scale it as quickly as possible across all of these? In some cases, it's relatively hard, obviously, from going from a microcontroller to an i.MX. It's not too easy, but we want to make that as easy as possible within each of those families or verticals. So let's take a look at some examples of this. First of all, we are looking to, in the middle there, in that RT area in the middle, we are looking to make a statement that if you're a Linux developer, you can get similar performance by going down to an RT, leveraging an M7 at up to 1 gigahertz and get really good performance, and it won't, and you can still get your similar performance as you would with a kind of a low-end i.MX running Linux. So we're using Zephyr to actually enable this device, and the data we've collected show excellent performance across a number of different operating system functions, and the data here shows pretty significant performance comparison versus Linux. So we're going to make Zephyr one of our platforms of choice in the middle, in that RT area, and then leverage the community to build on top of that, which I'll talk about here next. So let me take a machine learning example. There's many examples. I just picked machine learning because it's kind of popular these days. So like I said before, to really do machine learning properly, I think you do have to have some understanding of how this is going to scale from the end node to the gateway all the way up to the cloud. And the solution is different, right? Based on whether you want to do machine learning on a microcontroller, on an edge node, or even in the cloud. Most of the training probably will still be done in the cloud. That's pretty obvious. But then how do you deploy that down to a broad set of mass market devices easily? I think that's the challenge. And so our approach to that was, after number one and number two, establish the base, re-architect, is to leverage, again, the community and some of these open source components. With machine learning, again, you've got to make a choice across a number of different processing elements. This is an eye chart, but what it's really showing is from microcontroller all the way up to CPU and then GPU, the average performance expectation, and this is actually data that we've collected from MobileNet and other key machine learning benchmarks. The idea is the expectation of performance varies based on what kind of processing element you're using, right? So we do have to have a solution for all these different processing elements, and even others like DSP, or even a dedicated machine learning or a neural network accelerator. So the challenge is, how do you build a solution for all these different processing elements? Now, before I kind of show you what we did, if you tried to actually implement a machine learning system, there's a lot of what Google calls hidden technical debt. So there's a lot of tools, steps, processes that you have to go through to really, collect the data, filter the data, train the data, do feature extraction. All these different steps are required, and it's a lot of debt. It's something that you don't want to have to build from scratch, right? So this is something where, and then down there on the right, oh yeah, there's a little ML code as well, right? So there's a lot of steps that you have to go through to really develop a full system. There's a lot of great stuff out there. So leverage what's out there in the community, which is what we did, and tried not to reinvent all this stuff internally. I will admit, about 18 months ago, we thought we can do some of this better ourselves. It took about 6 months to realize that we couldn't, and now we're back in leveraging the community. So with all those Lego blocks, the idea is build your machine learning castle. And so what we did, this is probably not a very good looking castle, but I'll at least try to explain to you what we did. If you look at the, down at the bottom, there's a lot of different types of devices. Like I said, in a mass market kind of portfolio, you've got all these different types of devices that you may want to deploy machine learning on. Those green boxes are all the processing elements that in various combinations will get deployed to these different devices. I've got most of them there, most of the ARM cores, GPU, DSP, neural network accelerator. And obviously, there's more coming out every day, different forms of that, of those accelerators. Those get deployed in various ways on these different devices. So, but our approach was, on top of each one of those green boxes, what's the software stack that we can leverage, mostly from the community, to deploy machine learning? And that's what we did. So if you look at the purple boxes, an application on top of TensorFlow, probably a runtime if you're using Android or what have you, leveraging ARM neural network or SimSysNN, ARM compute library, et cetera. Build the stack, but leverage what you have, what's available in the community. And then our approach was to try to optimize that, okay? So leveraging the community, optimize it for each processing element across that wide range of different processor architectures. On top of that, we add some special sauce with, whether you want to do functional safety, some interesting security technology that we're developing, and a good user experience. That's where you would probably add some cross-cutting concerns and some differentiation. In the cloud, and the reason I put Think MATLAB there is because when I was a DSP guy, we would program down at the bare metal or an operating system. And then when things got a lot easier, when MATLAB came along and we would develop all of our algorithms in MATLAB and then just quickly deploy it very quickly to the target. With machine learning, I'm trying to draw an analogy that a lot of that will be done in the cloud now, and then you'll deploy it once you train the model in the cloud down to an end node or an edge node. And how that'll be done, it can be a Docker container, it can be some other OTA if you're going to an end node, but that's got to work pretty seamlessly, and that's actually pretty tricky. I think the edge node is a little bit easier because it can be something as simple as a Docker container with a machine learning model. But getting down to an end node where you've got a microcontroller, I believe, is a little bit more challenging. So this is the approach we are using to try to leverage open source components on top of a base of technology that's from the upstream, and then providing scale. So that's the approach we're using. We're halfway through this. We're getting there, but I think we're getting acceleration by leveraging the community. And so a couple examples of how this would deploy then. You take what I just showed you, and then I'm just going to show you a couple quick examples, like this RT with an M33, a power quad, which is it's an accelerator, machine learning accelerator, and a DSP. you can see that the technologies that I just showed you could deploy in different ways across these different processing elements. Now, it's not to say that you'll necessarily want to use all these at the same time, but they're available depending on the type of application you're trying to develop. So that was the approach. Develop those enablements for each processing element, deploy them in a single or heterogeneous multi-core device as necessary. But you have the building blocks available to you, and how you deploy them becomes an integration exercise. So this is one for like a microcontroller. For i.MX, it gets a little bit more complicated. This is an i.MX 8M with A cores, M cores, GPUs, and this is where you can start deploying a full system. So you can deploy through OpenCL machine learning on top of a GPU. You can leverage the A cores with Neon and with the acceleration provided by ARM there. You can even use the M cores to help you with sensor integration. And some of the things that Thomas talked about yesterday, like OpenAMP, you can use that to communicate between the M core and the A core. And you can start to build up a machine learning system by deploying these components, these building blocks across these different accelerators. And then again, it becomes more of an integration and optimization exercise, but you've got the components available to you once you build them once. That's the scale that we're trying to get to. And then going forward, we'll actually be building our own neural network accelerator, or actually working with partners on that. So as you can see, all different types of processing elements where you can deploy this technology. Our approach is get the building blocks and then deploy them rapidly onto these different systems. And then once you have all that, it becomes easier to work with partners. Just one example here that's relatively recent. Google just announced their Coral board with their TPU, their tensor processing unit, with our i.MX 8. The reason I point this out is because that engagement with that partner became a lot easier having gone through all the stuff I just got through talking about. So it enables partner collaboration when you've got a lot of building blocks already on the shelf that you can deploy or collaborate with. And so it allows you to also work more easily with partners. This Coral board is kind of the Raspberry Pi equivalent for AI, already at volume. You can go out and buy one today. Okay, so, and then I'm just about done. So I say create your own castle. Again, what I mean by that is if you've got these open source components and internal components, you can begin to put together whatever solution you want. This is a simple example from the microcontroller SDK build site where you can literally select the components you're interested in, some operating systems, connectivity stacks, machine learning enablement, pull together what you want, and just what you want, build your castle, download it, and then with some steps on how to get started, you can deploy these types of technologies fairly quickly. So that's kind of the approach we're taking, okay? So what we're doing, again, in summary, for mass market, again, our challenge was we had to try to scale very broadly across a large number of devices. So in order to do that, we tried to build building blocks, Lego blocks, whatever you want to call them, and then use those very rapidly to scale. Okay, we did that with basic enablement, and every year, you kind of go further up the stack. Those are the demands from the customer. We provide those building blocks, and then we integrate, optimize. It all starts, though, with having those 3 steps there done well, because markets are changing very quickly, and this approach, we believe, helps not in terms of both R&D efficiency, but also the ability to scale quickly. So that's kind of how we're leveraging the community, leveraging Linaro, open source, to allow us to meet this scalability challenge we have in front of us. So thanks very much.
So thanks very much, Rob. Really insightful stuff. Bullseye, open source, and then applying it to the AI model that you're using. I do think we do have a couple minutes.